Okay, you guys remember last year, 2020, what a year it was. And this guy, Ben Noll, whether you know him from Twitter and some amazing snow forecast, school closing percentages, mostly snow stuff. But I liked Ben because of the maps he was making about the upcoming hurricane season last year and in years prior. But really last year, his what we call thematic maps explaining something going on with a theme. And in this case, it was sea surface temperatures, anomalies, upward motion, precip, really gave us an idea of what we might have to face in the 2020 hurricane season. And so I thought I would have Ben back. We are putting this together now on February the 20th, 2021. So now we are a year later, and we're starting to see some very similar things. And so I thought I'd have Ben back through the miracles of Zoom, now that we're all familiar with that. And we'll discuss what we're seeing as we're coming up on a little over 90 days now until the 2021 hurricane season starts. So from New Zealand, I welcome Ben Noll to the Hurricane Outlook and Discussion. Thanks, Ben. Good to have you.
Yeah, great to be on, Mark. Thanks for that introduction. And yeah, man, it was quite a memorable year last year. And as these new model information start rolling out here for the next hurricane season, we're looking at these maps, and it's like another red flag alert. There could be another busy season potentially coming up. So I have put together the package of the early model guidance. It is still just February, but nevertheless, what we're seeing here in terms of the start of the hurricane season and kind of discussing similarities and differences from last year. So I will go ahead and share what I've got here. So let's give this a whirl, and just bear with me for a quick second here.
We're all used to how Zoom works. At least a cat or a mouse or whatever, like that attorney was that we've all seen the viral video that they were doing a deposition or something, and one of the attorneys was a cat.
That's funny. Yeah, I've seen so many of those Zoom calls where it's interrupted by, someone's having a very formal interview or something like that, and then one of their children walks in the background or something crazy happens. They go to the bathroom. It's wild, but this is the age we live in. And nevertheless, Mark, what you can see that sea surface temperature map. I take it, right?
Yep, you got the NME,
All right.
North American Multi-Model Ensemble, for those of you playing at home.
Yeah, so the NMME, kind of taking people behind the curtain, because that's one of the things, I think it's important to understand is where this information comes from. The NMME, as you say, Mark, it's a conglomerate of different models that come from the different producing centers in the United States. So if you have NCEP, you have NASA, a couple of the Canadians in the mix there, and they all are basically put in a mixing bowl and blended up with a blender, and we take the average of all of those. That's one way to assess it, is by taking the average, and we tend to use that average, especially in the longer range forecasting space, as it can smooth out those peaks and valleys. So it's one way of assessing the information. And when you have an average mark that looks like this, we see this blue right in the center of the frame here. And that is our cooler than average ocean temperatures in the Pacific Ocean, and it's that La Nina like flavor.
What time frame are we looking at here?
Yeah, so this is good call there. It's the heart of the hurricane season.
Oh yeah,
so that is
August through October.
October 2021. So we have this La Nina. We've had that since September, October of last year, 2020. Mm-hmm. And it's not really showing signs of that it's going to weaken with much pace. It seems like if it weakens, it'll be very gradual or slow moving. And there's even a subtle indication in some of the guidance that it could weaken a little bit as we approach summer. And then it actually could even ramp back up potentially as we work our way into the autumn fall season. So the thinking is that same climate driver that was with us last hurricane season, Mark, could be with us again.
And this far out in time, people might be thinking, well, that's a bunch of hooey. It's so far out. We're talking, it's February now that we're putting this together. This is for August through October. And we can get into this in more detail later if you need to. But, initially, why should we put any stock in this? I don't want to say believe it, because we don't want to sell this as being this is what is going to happen, but why should we put stock into this right now?
Yeah, so I mean, when it comes to seasonal climate models in general, you're not really looking for, what is the weather going to be at my house, in September or October in my backyard, right? These
Sure.
are about, trends. These are about, is it going to be warmer, cooler, wetter, drier, and where I live in the part of the globe. And when we do have an ENSO signal, be it La Nina or El Nino, that can help with the predictability of these models. So in this case, we've had that La Nina going back to last year, and we still have that cool signal in the Pacific. And what that can do is actually enhance the predictive abilities, especially in the global tropics, where the ocean temperatures are a very important driver of those sensible weather patterns. And that includes the Atlantic Ocean that helped us last year. So that helping us last year, I would expect that we're going to have that benefit again as
Right.
we head toward the next hurricane season. And there's a couple of other things that we look at. We look at the Indian Ocean as well. As the Indian Ocean changing?
Right.
And if the Indian Ocean is changing, that could tip us off to say, okay, well, maybe the Pacific or the Atlantic could be changing in the months to come. But we see quite a bit of stability. Things are fairly static right now with the system. So I would say overall, this is a signal. It's a piece of guidance that's telling us, that we need to be on the lookout and over the next couple of months, and especially as we go into the hurricane season.
So in a sports analogy, this is kind of like, and just pick your team and your sport, whatever it may be, that maybe you have recruited a very top ranked player, football, basketball, somebody signed with a baseball team, whatever the case may be, that's going to help things for that team. That's the analogy here. It doesn't guarantee championships. It doesn't guarantee wins, but you say a certain quarterback just signed or they're staying or coming back for college or whatever the case may be, it strengthens the argument that particular team, and I love sports and meteorology and how they mix and analogies, and I think that's a good way to look at it. It doesn't guarantee wins and or championships, just like looking at this doesn't mean we're going to have a very busy hurricane season, but this is a similar analogy to stacking a team that should have a favorable season ahead of itself in terms of sports. Would you agree with that?
I think that's a really good analogy, Mark, and I'll add a little bit to that. I mean, I'll go one more, and I'll say that there's this team actually has chemistry because
Ah,
we have not
very good.
seen the degradation of any of the climate drivers that were really with us last year. So we're seeing a continuation. The same players are on the field this year that were on the field last year, and perhaps that'll lend itself to more chemistry. A seamless
Sure.
flow from last season into this season.
And that really helps us to see these signals better. And the benefit is, I think a big part of this is for people to mentally understand what might be coming. We're not trying to scare people. This is the science here. These are the maps that are created from that science. It's real, it's out there, it's available. And I think it's good to be able to know ahead of time. And I often refer to stuff that we look at in our health, that you shouldn't ignore things with your health. You go to your doctor, they say, hey, look, your blood pressure is going up a little bit, your weight's going up a little bit. The doctor's not trying to scare you, but if you let it keep going, and then you come back in and your blood pressure's off the chart, and then he has to give you some bad news. That's the same thing as kind of ignoring things and say, I don't want to hear about the hurricane season. You put your head in the sand, so to speak, that old metaphor. I think it's best to know early to start to mentally prepare. And these are some really good tools to do that. So please understand, folks, this is a gift that we are given by the science. And then people like Ben that can produce these really nice maps, easy to understand, they're aesthetically pleasing. And then we in the weather world and the social media world get to explain them. That is what this is all about. So just think of it as a positive, not a negative.
Yeah, and that's a good way, I think, of looking at it, Mark. And we have different ways of kind of examining the different parts of the system here. So in this case, it's ocean temperatures.
Mhm.
Last year, we probably had, I would describe it as, 98 octane,
Yeah.
super fuel in the Gulf of Mexico and the Atlantic Ocean helping to fuel those storms. And what I like to look at, as you probably know, is a field called velocity potential,
Right.
which is basically leveraging that fuel, that 98 octane fuel, and then this is what I call the engine room.
Okay.
So how is the atmosphere reacting to the ocean anomalies, be they warm, be they cool, that it is sitting on top of. So it's a different way of looking at things. It's more of the atmosphere rather than the ocean. And this can help to tell a story as well. So what we have here is the velocity potential patterns for June of 2021, so a couple months from now.
Wow.
And in green, we have rising motion, and in browns, we have sinking air. And we tend to see that rising air over areas of warmer than average ocean temperatures, and the sinking air over pockets of cooler than average ocean temperatures.
Makes sense.
So what we're seeing here is quite a bit of sinking, as you'd expect, kind of across the Pacific in general.
Right.
But we have this pocket of unusually expansive rising air here across the Atlantic Ocean and right over Africa.
Yeah.
And this pattern, Mark, is very similar to what was observed in June 2020. So what I've got here is the June 2020 map. And if I flick between those two, have a look at that.
And this is why
I mean,
it's important. Really, this is, this is fact. Okay, this is not made up stuff. This is not hype casting. We go back and we look at and we see what we went through last year. That hindcast can be very, very helpful. And the comparative maps here, it's alarming. It is, and that's a good thing. Again, it's alarming because what does an alarm do? It wakes you up. And I want you to wake up to understand we may have a very busy hurricane season, and that affects maritime interests. That affects people in the islands. We're not just talking about the United States, the leewards, the windwards, the greater Antilles, the Bahamas, Central America. Through the power of social media, we have been, and this, people watch from all over the world. They follow what we're saying on social, and the Atlantic basin looks like very similar what we saw in June of 2020. And so if I understand correctly, this gradient that we have, that's a pretty focused area there over, what is that, the Gulf of Guinea? If I understand my geography of Africa and the surrounding waters, that's not a little signal, that's a pretty strong signal.
Indeed it is. And it's just amazing that it's sitting right on top of that same area that it was this time in 2020. So again, this is a prediction, whereas this is an observation.
Sure.
When you see those two things aligned, that raises the alarm bells, as you say. And in a moment, we'll look at the July map, because this particular model data set goes out to July. But one of the things you mentioned earlier, Mark, is why should we trust this information? Why should we be putting stock into it? And what I can say is that, in this field of climate modeling that, say, goes out anywhere from 1 to 6 months, there have been tremendous advancements over the last, say, half decade with, say, the ECMWF model, for instance, which is the one that we're looking at here, comes from the European Center. That model's horizontal resolution went from 80 kilometers down to 36 kilometers. I think that was in 2017. And when you increase the resolution of the model, it allows you to get these more precise and focused forecasts for areas of the globe, and thus makes the model prediction better. We see that in weather models. That same phenomenon is true for climate guidance as well. And not only have we increased the resolution, but the amount of observations that are going in to drive the initial analysis, the initial forecast of these models, has increased and continues to increase as we continue to use, say, satellite sea surface temperatures. Sure. We continue to use floats in the Pacific Ocean, Argo floats they're called. Yeah. And we use new sea ice models, and all of these things are feeding in to create that initial forecast. And things that would not have been feeding in, say, a decade or 2 decades ago, during the infancy of these, types of products. So we're really quite fortunate, I think, to have this level of information here in the year 2021, and to use it to our advantage, I think is quite important. Again, it's not fear factor here, but it is definitely something that says, okay, you're going to need to keep an eye on this.
Yeah, and I think that is something. I live in Wilmington, North Carolina, and I'm just a few miles from the Atlantic Ocean, and I don't want a hurricane hitting Wilmington, just like people don't want a hurricane hitting Miami or wherever they live. I get it, I really do. And so when I look at this and I can think, okay, it could be a very busy season as a homeowner, put aside my whole HurricaneTrack thing and my career and all that implies. I look at this and I say, hey, look, this is something I need to focus on and think about for my family. Again, just simple things like talking to my insurance agent, and just ahead of time, because we know how difficult that can be. These are the things you want to know in advance, and I keep spinning it that way because this is a positive that we know this far out that the potential is there for another very active season. And I keep coming back to that word. I think this is a gift that we are given from the science. So, all right. So that's from the ECMWF going out to June. And
Yes,
I think
sir.
right now out to July. And
Yeah, so we see the July map here, Mark, and what I see here when I look at this map is I see what's going on over Africa, and I'm like, boy, oh boy, because we know that's the generation zone as we get into those African easterly waves,
right.
usually during this toward the second half, the later part of the hurricane season, and if we have another active African monsoon here, which is what this would kind of hint at, what this would imply, that's not going to be good for those long track systems that emerge, in the main development region of the Atlantic and then come all the way across. So I'm not too fussed about this sinking cell that you see here over South America and over the islands. I wouldn't focus on that. We actually had the last couple of years, July, we tend to see that actually develop. So that's not to say, turn your guard down at all.
Right.
Keep an eye on Africa there and what's going on near Madagascar, as that will build up as we approach the heart of the season. So once again, I would have hoped to see, what you want to see is, June, something that looks totally different, that rising cell maybe over the Pacific, something like that. If you don't want an active season, but when it's sitting over Africa, Mark, if that ends up turning to be true, I'd be quite concerned what we then see from August through October.
And so the rising motion that we're seeing here helps to lead to what? I mean, kind of explain that a little bit.
Yeah, so at the what this is basically looking at is where air is diverging high up in the atmosphere, 200 hectopascals, very high ups, and where you have that upper air divergence, you have the low level convergence as well, and those two things together can lead to the formation of low pressure systems. So what we're seeing is a tendency for that type of setup here over Africa, over the deep tropical Atlantic Ocean, and where we're not going to see that setup is further west over the Pacific. So we usually see this this battle between, when the Pacific is warm, usually the Atlantic is cooler. When the Atlantic is warm, usually the Pacific is cooler. So what we're seeing makes physical sense. We're not seeing that pattern of upper air divergence over the cooler Pacific Ocean, at least in the model's mind. We're seeing that over Africa and over the Atlantic Ocean, where things are predicted to be warmer. So it makes physical sense when you kind of draw it back to first principles. This is, what I would expect to see before even drawing the map, So I would say that, overall, we are well aligned. The ocean is communicating with the atmosphere in this case. That's what we call coupling in the climate world. So the puzzle pieces, Mark, they're there. They are there, and certainly what I will do as we approach the season is continue to run the packages that I use to generate these images. And with every passing month, when it says the same thing, singing the same tune, well, that's another notch up that ladder of being concerned with the season to come.
And so that being said, how often, as an example, does the ECMWF update its seasonal guidance?
Yep. So that comes out the 5th of the month, once a month. Certain centers like the US, they run a model called NCEP, the CFS V2. And believe it or not, that runs 4 times a day. So the value of running a seasonal model 4 times a day is, in my personal opinion, is probably not that high, but there would be reasons for it. The UK is another well-known seasonal model that runs once a month as well. Mm-hmm. And some of the centers, Mark, have an interesting way of initializing or spinning up the model. Right. Sometimes what certain centers will do is they will stagger the members. So they'll say, let's say you have 50 different members that are being averaged together to create this output. Mm-hmm. What they may do is run 10 of those members on the first of the month, 10 of those members on the second of the month, third, fourth, fifth, so on and so forth, to create a bit of a staggered approach to the generation of the model output itself. Whereas other centers, they will just run all the members at once. So there are different techniques that you can use, that different centers use to basically try and create the best forecast.
So we've looked at anomalies for sea surface temperature, and we've looked at anomalies here for the 200 millibar velocity potential. How about precipitation? I'm assuming these models, and there you go. So this will show us, and again, the simplicity of this: drier is the brown, wetter is the green. Wow, that and this is the NMME. Takes us
August, October.
peak of the season. Look at that.
And I will explain this. This map is not just a traditional precipitation anomaly, Mark. This actually takes the model guidance from that period last year, so August to October 2020, and compares it with what is predicted for the upcoming August through October period in 2021, and it's a difference. So where you are seeing green in the Atlantic is the model actually saying it is going to be wetter than last season during that period, which is remarkable because last year during that period we were breaking records. So the fact that the model, again, we're very far out here. It's far out, but I acknowledge that. But the fact that the model, Mark, is showing in the Gulf of Mexico, the Western Caribbean, where we were having, it's showing wetter conditions in that area during that period this coming season compared to last year. And I mean, that's not what I expected to see when I first ran this. And that came up. I was like, oh my goodness, this is really something potentially. So, this is another way to examine the information, and it is, yeah, I would say of all the plots we looked at, when I saw this one first kind of come up on my screen, I run the Python code, I'm like, wow, wow.
Yeah, and when scientists are surprised by data, it's a challenge, and it becomes there's no other word for it. It's a challenge to try to interpret it and understand it. And if everything runs exactly the way you expect it, then things kind of get a little boring. And so when you have surprises, and this is surprising data, it's not what Ben expected, as he said. And I think we can look at it two ways, and it's just how you approach it. You could look at this and think, again, you're talking about something that's several months down the road. I don't have much faith in it. It's, they can't even forecast the weather 3 days out, blah, 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 blah. Or you can look at it as these climate signals have become easier to forecast by the aforementioned aspects that Ben talked about. The models are getting better, the resolution is getting better, the input's getting better, and so forth. And that we're seeing it this far out in this level might be concerning. In other words, if it's seeing it this much, this far out, imagine what it might see as we get closer. That you understand what I'm saying? It's like, man, it's like saying that so-and-so player on a basketball team has already scored 36 points in the first quarter. Yeah, it's like, that doesn't bode well for the other team winning, if he's only in the first quarter, knocking it down. This far out in time to see that kind of a signal, that definitely gets my attention, especially if you think about what Ben said, that this is comparing to last year. This is not just your typical anomaly map. So please take that to heart there, folks, that we got to pay attention to this upcoming season, no doubt about it. Every season, but again, this one may very well be another very, I dare say, hyperactive once again.
Yeah, and that is certainly, that word hyperactive, it was used ahead of last season, and man, oh man, like I'm still in my own way in awe of some of the guidance that was able to kind of foresee that, even as a scientist, even as being embedded within that, to see these products that people have really put a lot of time, a lot of effort, worked over the years to make better and better, and to see kind of the fruits of that. Of course, you don't want it to manifest in a record-setting hurricane season, but to see that, our abilities to foresee that, half a year in advance, is quite an accomplishment. I mean, the folks that were those founding fathers of meteorology, I think would just, man, if you could just tell them, hey, look where we are. Lewis Fly Richardson, some of the first ever guys that are making forecasts, 75 years plus ago. Here we are, talking about what may happen 6 to 9 months in advance. I feel like they would just find that fascinating. So it is quite impressive, Mark. And I will say one other thing about this map, And that is one of the questions I get from time to time on social media is, you may look at this map and you may see, oh, Louisiana, oh, there's shades of brown in Louisiana, so that means I shouldn't be worried about this upcoming season. Well, that's not what it means at all.
Right.
These models are just basically what you're looking for is a broad signal. So don't focus on the details here that Texas is brown and Louisiana is brown. It's just meant to show you that, okay, overall, the breeding ground for these systems, be it the Gulf of Mexico, the Atlantic, the deep tropical Atlantic, is predicted to be as active or more active in the models world than it was that time last year. And that, those systems can go anywhere once they form. That's a weather forecast. This is a climate outlook. So our ability to, predict exactly where they may go, it's impossible to do this far out. So don't let your guard down if you see something that's, more detailed on this map. It's not to focus so much on those finer details.
That's a great point. And, if you look at the entirety of equatorial Africa, all the way out into and just past the Cabo Verde Islands there, that density of green there for wetter, that is the breeding ground for tropical waves, these easterly waves. And that density in there that's remarkable. It really is. It's very telling. It's not splotchy and sporadic. That really, we might be, I think one takeaway from this, seeing the signals laid for a long track type of season where there's more activity in the Atlantic, which can go either way. If you get enough activity and the way that the steering patterns are, maybe enough stuff misses land, but you can't bank on that. But again, and it's weird because yes, you could have longer lead times, which is always nice. But then you see the density of the the greens there in the western part of the basin. So you just wonder, do they end up over there? There's a reason behind why the models are showing this. Some of the details we can't see. It's not like it starts in Africa off into the Eastern Atlantic and then it just goes away and it's just all brown west of there. We really need to take notice of this, folks. And again, I think it's a gift that we can see this far in advance. Here it is, February 20th, that we're looking at this and putting this recording together. And just like we did last year, we can go back, once we get to September, October of this year, we'll be able to compare and see where things ended up. You got anything else?
Well, I'll throw a couple more at you, Mark, because I think it's interesting enough to mention. And you see in the Central Pacific, have a look at how much kind of brown there is there around Hawaii, east of Hawaii.
Sure.
And that's suggesting that the Pacific pattern, that suggests suppression to me. So if I see brown there, that's all that much more kind of evidence that if the Pacific is suppressed, we usually see that uptick in the Atlantic. So the fact that it's suggesting it's even more suppressed than last year, that's perhaps even more notable. So we have the Pacific, and then that's the Eastern Central Pacific, and then the Western Pacific. Obviously, we have interest in the typhoon season, the Philippines. There's kind of, I guess, mixed signals across the Western Pacific in this outlook compared to last year. Perhaps not as wet across the Central Philippines, and a bit of a signal toward wetness in the north. But certainly of the entire global tropics, I think the biggest signal that we see across the board is what's going on from Africa to the Gulf of Mexico. So once again, we're going to be in for an interesting lead up to the season, I'd say, Mark.
And I think one thing I want people to understand is this does not suggest per se that we will exceed 30 named storms, that we will break last year's named storm record. I look at this and think of a season like 2017, 2004, maybe 05, where you have a very busy season, but an equivalent very high ACE. And that's the accumulated cyclone energy. And in that we would have long track hurricanes, very intense, lasting a long time, that also affect land. You could have a high ACE year like 2010, where, except for Bermuda, and Bermuda counts, I'm just saying, but no hurricanes made landfall in the United States in 2010. But we had a very high ACE year that year. Whereas a season like 2020, I don't remember off the top of my head what the ACE was, but it was not above 200. And I thought it would be early on. We had a lot of named storms, but your Eta and other Cat 5s that we had. You think I'd remember them off the top of my head? They were
Theta.
fairly short fused, right? Thank you. Fairly short fused. It didn't help. Laura intensified very quickly as it approached Louisiana, kind of going on that theme that we've seen since about 2016 with hurricanes intensifying close to land. This tells me, at least suggests to me, that we could be back in the sort of the era, if you will, for this coming hurricane season of long track hurricanes. And so high ACE and high impact, not a good combination.
That's right. And I guess the beauty of it is, Mark, is that we have still several months to keep an eye on the situation. And no doubt, as these things unfold, I'm sure I'll be chatting with you as we get more information, and look forward to sharing more information as it comes to light. So I guess, yeah, that's a lay of the land here, February 2021, as you we'll see in about a year from now what we're talking about. But and oh man, this is interesting enough from a scientific perspective, I think, to give folks at least an early heads up on that potential.
So bring your view back full screen so we can exit in proper.
Yep, let's do it.
We don't want to leave you as a little thumbnail to say goodbye. But look, there's two of you. That's like the Brady Bunch.
I only see one of me, so
that's funny. I see it. We'll see what Zoom sees anyway. Whatever.
All right.
So, yeah, Ben Noll Weather on Twitter. You guys know to follow him there. He'll post these maps often when they come out, of course. And we'll talk about it again. Anything you want to add before we let you go? To like anything to look for? The updates come around the first of the month. What should we be looking for? Sort of keys to the game in March's outlook.
Yep. So keys to the game. I'll roll with that. So we've got around the 7th or the 8th of March is when the NMME updates, and I usually post the ocean temperature, sea surface temperature anomalies, and the precipitation from that model. And then around the 15th is when the ECMWF data, I post the velocity potential. So those are kind of my three go-to maps, if you will. We've got the SSTs, NMME, precipitation, NMME, and I can compare and contrast from previous seasons, years. And then as we work toward the middle of the month, the broad scale upward motion plots come out. And those are the three that I would say look out for in March. So a couple of weeks from those models coming out. But yeah, keep an eye out at Ben Noll Weather on Twitter for those.
And how about the UK Met? Because you do the Super Blend, a very famous tool. Yeah.
Good one. Reminder there. So Super Blend, I averaged the ECMWF forecast with the UK Met. You basically can't find this anywhere else online. It's just something I do with the data. And what you'll see as we get closer to the season, because I only have the data out to 6 months for those models. So the March update will include August. So I'll have July, make that June, July, and August. So it's an early kind of look. Yeah. So I may, in fact, run the Super Blend script next month just to see what we're up against.
March Madness. We'll have it one way or another. Well, Ben, thanks very much for contributing. We appreciate it again. Ben Noll Weather on Twitter. You guys know where to find him. And if you don't, now you do. Thanks a lot, and stay cool down there in the waning days of summer in New Zealand. Thanks, Ben.
Thanks, Mark. Thanks for having me. Take care, everyone.